Welcome to an overview on reliability in Allegro X system capture. In this video, we'll discuss at a high level the 4 reliability features, which are Schematic Audit, Electrical Stress Analysis, Mean Time Before Failure, and Power Topology Analysis. There will also be a more detailed video on each reliability feature if you wish to find out more. To begin, Schematic Audit is similar to a traditional DRC system in many schematic drawing tools. What separates Schematic Audit from the competition is that it is net and pin aware, taking into consideration information such as the pin name, net name, attached power supplies, and even identifies common interfaces such as I2C or SPI for interface-specific checks. For example, connectivity identified as an I2C interface can be verified that a pull-up resistor is present on the SDA or SCL line. Schematic Audit organizes the results of more than 100 different rules into an easy-to-navigate dashboard, which is easily accessible from the project panel and shareable with all design stakeholders. Users can quickly cross-probe between the dashboard and the schematic, waive benign errors, and customize rule parameters to meet their own design standards. Electrical stress analysis, also known as EOS analysis, uses library and design data to identify all components in a design, assign standard models to those components, such as resistors, capacitors, or even transistors and diodes, and runs simulations to determine the probability of electrical overstress. To configure EOS analysis, System Capture automatically classifies components based on their reference designator and pin naming conventions. For more complex components such as ICs, each pin can be characterized by its pin use, such as input, output, or even power pins, and expected voltage levels are easily set in a table. These IC setup tables can also be easily exported and imported between designs. Variables such as the ambient temperature or component derating can also be configured to meet environment conditions. Electrical stress analysis outputs results to a similar dashboard that is interactive and can cross-probe with the schematic. It can easily be found in the Project Explorer, and designers can also export and share the results with their peers. Design MTBF, or Mean Time Before Failure, uses the electrical stress analysis results to simulate failure in time, or FIT, based on estimated operating conditions. Users can also modify parts and FIT values to quickly run what-if analysis on their designs. Component identification works just like EOS analysis, and results are displayed in much the same way as well. Using the dashboard, users can identify which components are a gating factor for better product longevity. Currently, MTBF analysis supports the MIL HDBK 217F and FIDES standards, in multiple different environment and simulation profiles respectively, and there are more standards to come in the future. And finally, power topology analysis can be used to generate a power distribution network, or PDN, to visualize a schematic and analyze DC power consumption in a PCB design. This analysis can be run in the early stages of a design to identify any potential power bottlenecks, or at the end of a design for sign-off. The setup for power topology analysis should look familiar by now, and utilizes the same component identification engine as EOS and MTBF analysis. And the results are viewed in a similar cross-probe friendly dashboard. The running theme of design integrity is to reuse all the information that is already present in each library component's parameters and run quick analyses in System Capture. Schematic and PCB designers can expect better quality of results by running analysis early throughout a project's development rather than at the end or even on a test bench. If you'd like to find out more about any of these reliability checks, check out our deep dive videos into each individual feature. Thanks for watching.